So, have you ever actually stopped to wonder how your phone magically recognizes your face the literal second you pick it up? Or how tools like ChatGPT string together sentences that sound completely, undeniably human? You know, we interact with these wild systems every single day, kind of just taking them for granted. But what is the actual machinery working behind the screen? Well, welcome to this explainer. Today, we're going to treat artificial intelligence kind of like a Matryoshka doll. You know, those beautiful Russian nesting dolls? Instead of getting completely overwhelmed by all the technical jargon out there, we're just going to continually open up this doll, layer by layer, to reveal the fascinating subsets hidden inside. By the end of this, you'll see exactly how all these buzzwords fit together. Okay, let's dive into this roadmap. We'll be covering 1. Welcome to artificial intelligence. 2. Machine learning basics. 3. Types of machine learning. 4. Inside deep learning. 5. Generative AI and NLP. And 6. Computer vision.
Alrighty, kicking things off with Section 1. Welcome to artificial intelligence.
Let's start with the absolute outermost, broadest shell of our Matryoshka doll. When we say artificial intelligence, we're really just talking about any technology that allows a computer or system to perform a task that typically requires human-like intelligence. Think about how naturally good humans are at recognizing patterns or understanding speech. Anytime a machine replicates that, whether it's Siri understanding your voice or an automated camera reading your car's number plate to issue a traffic ticket, that is AI in action.
Moving right along to Section 2, Machine Learning Basics.
Now, let's pop open that first doll and reveal the absolute most important subset inside, which is machine learning. Honestly, the vast majority of the AI we interact with today falls squarely into this specific subdomain. So, the crucial point is this massive paradigm shift in how we actually program computers. See, in traditional programming, a human gives the computer the input and the logic, the hard-coded rules, and the computer spits out the output. But machine learning flips this entirely. We give the computer the historical input and the historical output, and get this, the machine figures out the logic all by itself. It literally learns the rules purely from data.
To pull this off, machine learning relies on a core two-step flow. Step 1 is training. Think about it like this. Say you work at a bank. You feed the machine thousands of past loan applications. That's your input, and whether those people actually paid back the loan or not, that's your output. The machine learns the hidden patterns, like how credit scores or salaries correlate with paying back a loan. Then comes Step 2, inference. Now, when a totally new applicant walks in, the machine uses that learned logic to make a prediction, approve or reject.
Which brings us to Section 3, Types of Machine Learning.
Machine learning isn't just a monolith. It actually branches out into 3 primary types, depending on the kind of data we feed it. The first branch here is supervised learning. Basically, this is exactly what we just talked about with the bank loans. It's when models learn from clearly labeled data. You're essentially handing the machine an answer key to study from, directly mapping a specific input to a known output.
And this powers a ton of real-world stuff. We use it for classification tasks, like your Gmail sorting incoming emails into predefined categories of spam or not spam, or sorting images into cat or dog. We also use it for regression tasks. Now, regression doesn't sort into categories, it predicts a numerical value. So when Zomato or Swiggy predicts your food is going to arrive in exactly 43 minutes, based on distance and past rider data, yep, that is supervised learning at work.
But wait, what happens when we don't have an answer key? Well, that brings us to unsupervised learning. This is used when we have a massive pile of raw, completely unlabeled data. The machine's job is to find the hidden patterns, relationships, and clusters totally on its own. It literally takes chaos and organizes it into structure.
You honestly experience this all the time. If you open a news app, it's already clustered all the tech articles together and the sports articles together without a human ever tagging them. It's also used heavily in cybersecurity to detect anomalies. Say a user normally logs in from London, but suddenly logs in from 5 different cities in 1 minute. The system immediately flags that outlier. And of course, there's market basket analysis. This is how Amazon or Blinkit magically know that customers who buy bread generally also buy milk, allowing them to recommend items bought together.
Then we have the third branch, reinforcement learning. If supervised learning is a student with an answer key, reinforcement learning is honestly a lot like training a dog to sit using treats. The model, or the agent, learns by directly interacting with an environment. It makes a move, and if it's a good move, it gets a mathematical reward. If it's a bad move, it gets a penalty.
The ultimate goal is to simply maximize those rewards. Because this relies so heavily on trial and error, it is absolutely perfect for complex, multi-step environments. We use reinforcement learning to build AI that consistently beats human grandmasters at chess or Go. We use it to navigate games like Snakes and Ladders, where the agent learns to seek out ladders for rewards and avoid snakes to prevent penalties. It's even the technology helping robots walk and self-driving cars safely navigate chaotic streets.
All right, pop it open the next layer. Section 4, Inside Deep Learning.
So deep inside machine learning is a totally fascinating subdomain called deep learning, which uses artificial neural networks to tackle messy, unstructured data like video and audio. Training these complex networks boils down to a continuous loop. In step 1, called forward propagation, information flows through the network and it makes a guess or prediction. In step 2, backward propagation, the network compares its guess to the true expected answer, calculates exactly how wrong it was, which we call loss, and then moves backward to adjust its internal parameters. Guess, check, and correct. Literally millions of times.
Now, what's really interesting about this is an incredible analogy to understand how it actually works. Think of a college grading system. If a teacher sees students are skipping class tests because midterms are worth more, the teacher adjusts the grading weights, maybe lowering the midterms value to 30% and bumping class tests up to 30% to fix student attendance. Neural networks do the exact same thing mathematically. They constantly adjust the mathematical weights of their connections during backward propagation to force the final prediction to be more accurate. But why do we even need these special deep learning networks instead of standard machine learning? Well, to put that into perspective, think about this number: 3 million. If you want to train a model on a standard colored image that's just 1,000 by 1,000 pixels, because it has red, green, and blue color channels, that is 3 million input values that a single neuron in the network has to compute. Standard algorithms simply choke on this massive scale of unstructured data, which is exactly why deep learning is an absolute game changer today.
Diving even deeper, here is Section 5, Generative AI and NLP.
Now let's pull apart the doll one more time to reveal its innermost core. And I want to really emphasize the word new here. While traditional machine learning predicts a delivery time or sorts an image into a cat or dog category, generative AI creates content that literally did not exist before. It generates completely new text, audio, images, or even computer code. And this brilliantly illustrates the landscape we find ourselves in today. An absolute explosion of tools powered by natural language processing and large language models, trained on massive amounts of internet text. If you want new text, you use ChatGPT, Claude, or Gemini. If you want new images, you prompt Midjourney, DALL-E, or Stable Diffusion. And if you're a programmer needing new code, you lean on GitHub Copilot. It's a completely new paradigm of human-computer interaction.
And finally, Section 6, Computer Vision. Before we wrap up the whole shebang, we have to briefly touch on one final, incredibly important application of these neural networks, which handles what machines actually see. This field is called computer vision. Because processing 3 million pixels at once is just too much, computer vision uses specialized architectures called convolutional neural networks, or CNNs. Instead of looking at every pixel simultaneously, CNNs scan small patches of an image at a time, looking for edges, corners, and shapes, which perfectly optimizes the data. This is the exact technology reading grids of pixels to make your phone's Face ID work and allowing self-driving cars to interpret pedestrians and stop signs out in the visual world. And there you have it. We've opened the AI Matryoshka doll all the way from the broad outer shell of artificial intelligence, down through machine learning and deep learning, right into the core of generative AI and computer vision. So I'll leave you with this. Looking at all these incredible technologies, which branch of the AI Matryoshka doll do you find the most fascinating to explore next?